It is the right idea, but it is the wrong time. An infamous quote from my good friend, John Dalton. And John Dalton, remember, he came up with the first atomic theory. But he also came up with Dalton's law of partial pressures, which he stated that a mixture of two or more gases which do not chemically react, when you mix these two together, the total pressure is the sum of the individual pressures of these gases. Way to go, John Dalton. You are truly a genius for saying this. So, if you take the sum of the individual pressures, so if you have a pressure of 2.4 atmospheres, and you add it to a pressure of 6.0 atmospheres, you will have a total pressure of 8.4 atmospheres when you add the two together. Go figure. Genius. Please note that these have to be at the same temperature and volume, and the equation we use is P total equals PA plus PB plus PC plus PD, and so on and so on. Okay, let's look at an example of Dalton's law of partial pressures. There is a container of oxygen, xenon, and helium in it. The total pressure is known to be 972 torr. If the pressure of helium is 6.73 psi and the pressure of oxygen is known to be 74.1 kilopascals, what is the total pressure of xenon in torr? Well, we know that the total pressure is 972 torr. The pressure of helium, and I will use PHE to signify the pressure of helium, is 6.73 psi. The pressure of oxygen is, and I'll use pressure of O there, for 74.1 kilopascals. We are looking for the pressure of xenon in torr. Okay, so we have the same units here, so I have to convert my PSI over to torr. So 6.73 PSI, PSI on the bottom, torr on the top. Swish, swish! Okay, the periodic table says 14.7 PSI. Periodic table says 760 torr. So we get a new pressure of 348 torr. That is our new pressure of helium that we are going to use. Okay, move your hand out of the way, Mr. Harrodum, so they can see what you're writing. Now we are going to convert the kilopascals also over to torr. kPa on the bottom, torr on the top. Swish, swish! Let's see here. kPa according to the periodic table is 101.33. Torr is 760. And we get a torr pressure of 556 torr. So the new torr pressure is 556 torr. So the equation I am going to use is P total equals P of helium plus P of oxygen plus the pressure of xenon. You take the individual particles, you sum them together to get the total pressure. So then this is like 972 torr, and this is 348 torr, and this is 556 torr, And we're going to get the pressure of xenon. And we get the pressure of xenon to be 68 torr, which is Dalton's law of partial pressures. Dun, dun, dun. So usually if I see something about a mixture in a problem, I'm thinking Dalton right away. Okay, that's what I do. Okay, a mixture of three gases is known to have a pressure of 1.27 atmospheres. If the two gases have the same partial pressure, and the third gas is known to be 650 torr, what is the individual pressure of the other two gases in torr? Well, here we know that P total is equal to 1.27 atmospheres. We know that the third partial pressure is 650 torr. And we know that pressure 1 and pressure 2 are equal to something in torr. So now we need to convert our atmospheres over to torr, of course. 1.27 atmospheres. T chart, scribble, scribble, scribble. ATM to torr. Swish, swish! Periodic table says 1 atmosphere. Torr, 760 torr. 950, Mr. Harridan. 965.2 torr. So we cross this number out, and now we are using 965.2 torr. Equation we're going to use here, P total equals P1 plus P2 plus P3. 965.2 torr equals X plus 650 torr. Subtract 650 from both sides. 2x is equal to 613 torr. At least I think it is. Yeah. Divide both sides by 2 and you get a partial pressure of 158 torr. And this is infamously known as Dalton's law of partial pressures. Okay. Moving on to the next example. If you need a good challenge at gas laws, do this problem here. This is the challenge. Dun dun dun. Okay. Here he has a 200 milliliter sample of oxygen gas at 790 torr and 20 degrees Celsius. There's a 300 sample of xenon gas at 600 torr at 80 degrees Celsius. Transports both of these gases into a third container whose volume is 1.75 liters and the temperature is maintained at 25 degrees Celsius. What would be the total pressure in torr of the new container? Okay, so we have volume 1, 200 milliliters. We have pressure 1, which is 790 torr. And we have temperature 1, which is 293 Kelvin. Okay. He has a 300 milliliter sample. So we have a volume 2, 300 milliliters. We have a pressure 2 of 600 torr. And then we have 80 degrees Celsius. 80 plus 273 would be 353 Kelvin. Well, you must be like confused because there's like no variable yet. Okay, it's placed into a third container, V3, which is 1.75 liters. Okay, hopefully we know that 1.75 liters is really 750 milliliters, of course, because I have to keep my volumes constant. What would be the pressure, total pressure in torr? So we're looking for the pressure in torr. Okay. If the temperature is maintained at 25 degrees Celsius, which is 298 Kelvin. So we're looking for the pressure in torr. Those are all my wonderful variables. Okay, so here we go. Here's this good fun here. So the first equation I'm going to use here is P1 V1 over T1 equals P3 V3 over T3. Okay? That is taking into account just the oxygen. Okay? Then I also have to take into account the xenon. Now, xenon's not going to react with oxygen because it's noble gas. So we're going to use this equation, P2 V2 over T2 equals P3 V3 over T3. Once I get those two answers for P3, I'm going to add them up and I will have a total pressure. So, the first one I am going to do here is 790 torr times 200 milliliters over 293 Kelvin equals P3 1750 milliliters over 298 Kelvin. Jeez, that's not even a big temperature increase there. Anyways, I believe I get the first pressure is equal to 91.8 atmospheres. Now I'm going to do the problem again here. So the next one I'm going to do, I use 300 milliliters and 600 torr. Over 353 Kelvin equals P3 1750 milliliters over 298 Kelvin. Give them a time to absorb that wonderful information, Mr. Harriman. I believe the pressure here will be 86.8 torr. So then the total pressure is, you add 2, 179 torr. This is what I would call combined with Dalton. That's what I'll call it. It's no official name, but that's what I will call that problem. If you're trying to figure out what the answer is, the answer was 179 torr. Slight challenge for some of us. Okay. You guys are total champions. The legend is out.